This is a problem from section 6-4, problem similar to your homework assignment. It says here that there are 3 randomly selected households that are surveyed. The number of people in the households are 2, 4, and 9. Assume the sample size of n is equal to 2 are randomly selected with replacement from the population of 2, 4, and 9. Find all the possible samples. So we're going to create a little table here with all the possible samples. And so the first sample could be, if this is with a replacement, we can select the sample of 2 and put that back in there and then happen to select that same household of 2. So this is one possible sample of size 2. Another one could be if we select a sample size of 2 and then we put it back, and then the second time we get a sample size of 4 or a household size of 4, then here's another sample. And then we can do that again. Maybe we got 2 the first time and then we put it back and then we randomly select it again and we got 9. So there are 3 possibilities so far. And then we can just switch around this sampling distribution by selecting sample sizes of size 2, and then our next batch would be 4 and 2, 4 and 4, 4 and 9, and then we got another 3 more possibilities with 9 and 2, 9 and 4, and 9 and 9. So these are our samples. We have 9 samples altogether, and let's figure out what to do with them. Part A says to construct a probability distribution table that describes a sampling distribution of proportion of even numbers when a sample of size 2 are randomly selected. So what we need to do, let's go back to our sample list and let's figure out the proportion of even numbers. Since there's only 2 of them, I think this is a fairly easy thing to figure out. So what we want to do for each of these is to figure out what the proportion of even numbers are. So what we want to do here is that for each sample we want to try to figure out what the proportion of even numbers are. For this first one, 2 is even and 2 is even, and so both of them are even. There's only 2 of them, so that's 100%. So we'll just give it a number 1. Here we have 2 and 4, and they're both even, so that's 100% again. For this next one, 2 is even, but 9 is odd. So half of your sample is even, and so that's only 50%. We'll call that a 0.5. And so the next one is even and even again, so that's 100% even, 100% even. The next one, we have 1 even and 1 odd, so that's 50% again. This is 50%, this is 50% even, and then now the next one, they're both odd, and there's only 2 numbers, and so that's 0% even, because it's all odd. So these are the proportions for your sample. Now let's go back to this idea of constructing a probability distribution table that describes a sampling distribution of the proportion of even numbers. So let's take a look at all the possibilities that we have. We could possibly be a 0, a 0.5, or 100%. So these are your proportions. These are the choices of proportions that we have. There's only 3 choices here. So what's the probability that we get 0? Now remember that there was 9 different possible samples that we have here, and one of them, only one, has a 0 proportion of even numbers. So we can call that 1 out of 9 probability. Now, how many of them are 50% even? There's 1, 2, 3, and 4. So 4 out of 9 are even. And then how many are 100% even? There's a 4 out of 9 as well. So here is our probability distribution table of the even numbers. The second part is asking us to compare the population proportion to the mean of the sample proportions. So let's remember that the whole population was just a population of 3 numbers, 2, 4, and 9. So this is your whole population. Now, what proportion of this population is even? Well, we see 2 even numbers out of 3. So the population proportion, let's call that P, is equal to 2 out of 3, so that's just 2/3. Now the next one, they want us to find the mean of the sample proportions. So what we want to do is we want to take a look at the sample proportions and find the mean, the average. How do you find the mean of a set of numbers? Well, you simply add them up and you divide by the number of numbers there are. So we know that there's 9 of them, we just have to add them up. So let's add them up. We have 1 plus 1, that's 2, 3, 4, and then we'll count the halves. That's 5, and then that's 6. So the mean of the sample proportions is equal to, what did we count? We counted 6 out of 9 possibilities. And so we know that that simplifies to 2/3 or 0.6667. Okay? So we see that the population proportion, which is 2/3, is actually equal to the mean, which is also 2/3. And so with that, we can conclude that the proportion is a good target. The sample proportion would be a good target for the population proportion. So that would make the sample proportion a good estimate. Okay? All this stuff is kind of preparing us for our inferential statistics studies. And what we're going to do is we're going to develop ways and methods of estimating a population parameter like proportion or a variance or a mean. It turns out that those 3 parameters are the ones that can be used where we can find sample information and make a generalization about the whole population. Okay? Alright, so hopefully this will help you get through some of the homework problems that are related to this section. Good luck.